Now, when I think about the properties of logarithms, you have to think about the relationship between the exponential function and the logarithmic function. So if you remember, the exponential function takes x to y, and then the log function brings y back to x. Now, in the world of the exponential function, he has all kinds of things that happens to him, and one of the things that we know is called the properties of exponents. Is the properties of exponents. So that if I'm looking at these two guys being interrelated, this whole set in the domain has the properties of exponents on it. Why? Because you're taking a base to some power, right? And so if I say that b to the x times b to the y is b to the x plus y, that when I bring that quantity back, there's got to be, that it has to land in the same place. That's why that what we have that matches the properties of exponents that we're going to explore now on this guy is going to be the properties of logs. You can say the properties of logarithms, but to me that's too much to say. So logs says it all, although sometimes you may feel like you want to beat yourself with one. So the first thing we're going to take a look at is what we call the product rule. The product rule is related to the property of exponents that says that b to the x times b to the y equals b to the x plus y. If the bases are the same, you add the exponents. This is the rule that brings it back so you land in the right place. So if you have the log of a product, it turns into a sum. The argument is a product, and then what you have is the logs of the individual factors. So this is the guy who's related to the b to the x times b to the y equals b to the x plus y. Now remember, and it's a hard thing now to think about, remember, because we don't know what a logarithm is. We really don't have an understanding as to what it is. Until you have to work with it and you use it extensively, you don't. So what you end up doing is learning how, like I did, you learn how to manipulate it, then you don't know what in the heck you are manipulating until, for me, I had to teach it, and then I had to figure out what in the heck it really was and how it fit together. But I also had a benefit that you don't have anymore. And that is the fact that we used to use these big tables instead of calculators, and we were dealing with things called characteristics and mantisses. You don't even hear that word in books anymore. And that taught you what essentially an exponent was, or what a logarithm was. The logarithm was an exponent and how the pieces fit together. We've lost that with our calculators. So now we just manipulate it, and then in your science classes, hopefully you do enough of it where it begins to make a little bit more sense, especially in chemistry. And so that says I have the argument is a product. It turns into the sum of the individual factors. So if I have the log of 4 times 16, it's the log base 2 of 4 plus the log base 2 is 16. I have the product of two things. It becomes the log of the individual, the sum of the logs of the individual factors. That's the rule. Log base 10 of, now what you can take apart, you can put back together. Log base 10 of 0.01 plus log base 10 of 1,000 is log base 10 of, this is a sum, so a sum turns into a product, and 0.01 times 1,000 is log base 10 of 10. So you can take these things apart and bring them back together. So let's take a look at what this guy actually is. We have the log base 8 of 13y. When I look at this, this is the log base 8. It's 13 times y. So I've got two factors. This becomes, using the property of logs, the log base a, or base 8 of 13 plus log base 8 of y. This is 5 times x plus 1. So I've got two factors. So it becomes log base 9 of 5 plus log base 9 of x plus 1. So it's the sum of the logs of the individual factors. The bases are the same, you add the exponents. Logarithm is an exponent. So I'm adding two exponents. Because what the logarithm does is takes it back to, the y values back to exponents. Now what's apart can be put back together. So that says if I have a sum, it becomes a product. So this is log of 2 times x. Or you can write it as the log of 2x. You don't have to put the times in there. And you don't have to put the 10 because if there's nothing there, you assume it is a 10. It's just like with square root. If there's nothing there, you assume it is a 2. And if I have log base 2 of x plus log base 2 of x minus 3, there is two arguments, so this is log base 2 of, a sum turns into a product. You can only do that if you have the same basis.
So when you multiply it, you're just using...
I would just leave well enough alone and quit while I was ahead.